Good day, students. Welcome to math.serve.com. This is problem number 4 on our test on applications and derivatives. We're going to focus on critical points in this question. All right, so question 4 reads, find the x values of the critical points of the function f of x equals x minus 2 to the 1/3 times 3x minus 1 to the 2/3. Okay, so how do we find the critical points? Let's go ahead and review that real quick. The critical points are where the first derivative is equal to 0 or the first derivative does not exist, okay, or where it's undefined. All right, so let's go ahead and find the derivative of this function and then see what values of x causes the derivative to obtain a value of 0 or causes it to be undefined. Okay, so let's rewrite the function. F of x equals x minus 2 to the 1/3 times 3x minus 1 to the 2/3. Now, how do we find the derivative of this function? If you notice, this is the product of two functions, right? So we can call this function u and call this function right here v. Okay, so we have u and v. We can use the product rule. What is the product rule again? uv prime is equal to vu prime plus uv prime. Since addition commutes, you can write it in the other order too. Okay, so we're going to use this formats to find the derivative of this function. Okay, one thing you want to note is that these two functions that we're multiplying together are composite functions. Okay, so the inner function here is x minus 2 and the inner function here is 3x minus 1. When looking for the derivative of composite functions, what rule do you use? You have to use the chain rule. Okay, so we are using the product rule and the chain rule within the product rule in finding the derivative of this function. Okay, so let's go ahead and set this up. F prime of x is going to be v, which is 3x minus 1 to the 2/3, vu prime, x minus 2 to the 1/3 prime, so this is v u prime plus u, which is x minus 2 to the 1/3 times v prime, which is 3x minus 1 to the 2/3 prime. Okay, all right, let's go ahead and find u prime and v prime and insert it back into this equation. So we have f prime of x equals 3x minus 1 to the 2/3. Now we're going to apply the chain rule here. If we have differentiate the outer function here is x to the 1/3 and the inner function u is x minus 2. Okay, so we're going to differentiate the outer function, which is 1/3 x to the negative 2/3. Insert the inner function back in there and then multiply it by the derivative of the inner function, which is just 1. Okay, so let's go ahead and do it. So differentiating the outer function, we'll have 1/3 x minus 2 to the negative 2/3, applying the power rule to x to the 1/3. Now if you differentiate the inner function, term by term differentiation, derivative of x is just 1, derivative of 2 is 0. Okay, plus x minus 2 to the 1/3, that's u. V prime, we're going to apply the chain rule again. Okay, so here the outer function is x to the 2/3 and the inner function here is 3x minus 1. So in the chain rule, we'll differentiate the outer function, 2/3 x to the negative 1/3, and evaluate it at the inner function, 3x minus 1, times the derivative of the inner function, which is just 3. Okay, so let's apply the chain rule here. We're going to have 2/3 times 3x minus 1 to the negative 1/3. That is the derivative of the outer function evaluated at the inner function 3x minus 1 times the derivative of the inner function, which is just 3. Okay, so there you have it. All right, so let's go ahead and rewrite this in a format where we can combine them into one rational expression. So we're going to have 3x to the 3x minus 1 to the 2/3 divided by 3 using the properties of exponents. This can be written as x minus 2 raised to the 2/3. Okay, and then times 1 doesn't change anything, plus we're going to do the same, apply the same idea here. We'll have x minus 2 to the 1/3. Now notice we have a 3 downstairs here and a 3 upstairs here. Divide that out. So we can have a 2 over here divided by, and then using the reciprocal property of exponents, this negative right here, this term with a negative exponent gets reciprocated, so it becomes 3x minus 1 to the 1/3. Okay? Now, to combine these fractions so we can set the denominator to 0 with ease to calculate when the derivative is non-existent, we're going to have to find the LCD. Okay, so let's find the LCD and combine these two rational terms. So we have a 3 here, we need a 3 here, top and bottom. We have x minus 2 to the 2/3 here, so we also need an x minus 2 to the 2/3 top and bottom. Okay? All right, we're almost there. Now we also need a 3x minus 1 to the 1/3 here, so we have to multiply top and bottom. 3x minus 1 to the 1/3, and then 3x minus 1 to the 1/3. Okay? Now we are going to have something nice happen. All right, so we're going to multiply the numerators. So we're going to have f prime of x. Now, if you notice, these two quantities here have identical bases. So we can use the product property of exponents to express it as 3x minus 1, and you add the exponents. Anytime you multiply exponents with the same base, you add the exponents. A third plus 2/3 is just 1. Over here we have 2 times 3, which is 6. Same story here, you're multiplying exponents with the same base, so you add the powers. A third plus 2/3 is just 1. Okay? Now we're going to go ahead and divide that by the product of the denominator. If you do that, we're going to have, what are we going to have? 3 times 3x minus 1 to the 1/2 times x minus 2 to the 2/3. Okay, let's go ahead and simplify it a little bit more. So we're going to have, in the numerator, we have 3x, and then we can distribute the 6 to these two values in the parentheses. 3x plus 6x is 9x, and then we have minus 1 minus 12, which is negative 13. All right, so there goes your numerator divided by the denominator, which is 3 times 3x minus 1 to the 1/2, to the 1/3, not 1/2. Where did that 1/2 come from? To the 1/3 times x minus 2 to the 2/3. Okay, now to find the critical points, we need to find where the derivative is equal to 0 and where the derivative does not exist or where it's undefined. Okay? Let's do the first one, where it's equal to 0. So what we'll do here is simply take this derivative expression we found and set it equal to 0. Okay, so we have 3x minus 1 to the 1/3 times x minus 2 to the 2/3 equals 0. If you put this over 1 and cross multiply, you end up with 9x minus 13 equals 0. If you solve for x, you have x equals 13 over 9. Now, where is it undefined? Or where does it not exist? Well, the output is undefined when the denominator has a value of 0. So what we're going to do is extract the denominator and set it equal to 0. Okay, so let's go ahead and do that. 3x minus 1 to the 1/3, x minus 2 to the 2/3 equals 0. All right, so if we use the zero product property, we can have 3 times 3x minus 1 to the 1/3 equals 0, or x minus 2 to the 2/3 equals 0. All right, let's go ahead and solve this one. Divide both sides by 3. You have 3x minus 1 to the 1/3 equals 0. You raise both sides to the third power. Raise this to the third power. Raise this to the third power. And that yields 3x minus 1 equals 0. If you add 1 and divide by 3, you have x equals 1/3. Here, what you do is you raise both sides to the 3/2 power. Okay? 3 over 2 raises to the 3 over 2, so we can get rid of this exponent here. So we're left with x minus 2 equals 0. Add 2 to both sides. X equals 2 is your other critical point. Okay? So our critical points are x equals 1/3, 2, and 13 over 9. So that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on Math Got